forward and backwards. All right, great.
How is everybody today? My name is James Whiting. This is How Gown. We're both engineering majors, mechanical, chemical. We're both freshmen. This is our spring semester this year. And there we go. So our project idea is the iHand, and it mostly revolves around basically integrating retinal scanning and eye tracking technology into simple sub-forearm prosthetics. So here are some statistics regarding amputation in the USA as well as some global statistics. In 2009, $8.3 billion in revenue were generated from the amputation costs in hospitals alone. 2 million individuals are suffering from limb loss today in the US at the moment, and there's roughly 185,000 per year, just again, in the US. Half of these are due to trauma, half are due to vascular diseases, and a very small percentage are actually birth defects in and of themselves. And so we are focusing, once again, on the majority, the upper extremities as well as sub-forearm in particular. So our problem right now is that prosthetics in and of themselves, highly functional, high technology prosthetics are expensive to come by. Myoelectric, which reads the electrical signals sent by the muscles in your arms or in your legs, depending on what prosthetic you're dealing with, are very expensive. They can go up to $100,000. The leader right now in prosthetics for sub-forearm myoelectrics is RSL Steeper, I believe, yeah. With a V-Bionic 3-arm, it's approximately $30,000, which is very functional, but it's also a very high price range. They're an extremely successful company with that price tag. However, the patients have a difficult time, A, talking to insurance companies about why they need such a prosthetic with that price tag itself, as well as just acquiring it in general. Reinnervation is also another promising part of the industry, which is actually working with full arm prosthetics. It's very bulky, very heavy, very intensive on the patient. A lot of surgery is required. It's actually rerouting the nerves in your upper arm into your chest. So whenever you would, say, bend your physical arm, instead you would see the contractions in their chest and it would operate the mechanical arm itself. Very interesting, very costly, between the cost of the mechanics as well as the cost of the hospital bills, surgery, everything. So that's where the opportunity comes in our idea. We are proposing something that is entirely non-surgical and runs purely off electrical power with a bit of eye tracking technology incorporated, which all of the technology in both of the industries are there. Tobii Technology is a company in the UK right now which produces eye tracking sensors, which have been incorporated in several households, also among some gaming devices. They're really a multicultural, industry leader with this eye tracking technology. One example of how Tobii is integrating this into medical devices is a former X Game competitor on a bike tried to do a double backflip, landed on his neck, ruined his career. He's bound to a wheelchair for the rest of his life, has no movement except for his eyes itself. As a result, Tobii used these sensors, incorporated them into his house. He now has the freedom to go about, operate TVs, operate computers, internet, everything he needs to do, phones, everything to get by just day to day. And that's what we're hoping to do, incorporating these into the sub-forearm prosthetics. So what we need here is a $5,000 Kickstarter, hopefully from the competition. And what we want to do is unite Tobii Technology with the university itself, as well as whatever graduate students are interested, professors are interested, any students in and of themselves. That way we have a consistent group going within the university after we grow out of the university itself, if by then it hasn't turned into a business already. The main idea behind the hand itself is that the retinal scanners, you'll look at them almost in a binary coding sort of way, and it'll say, yes, the individual is looking here, no, the individual is not looking here, and it'll repeat a certain motion over and over again. The main focuses would be rotating about the wrist, closing and opening of a fist, and pinching of these two fingers, as well as closing of these two simultaneously and these two simultaneously. So relatively simple mechanically. It's just difficult to go by when we have no means to do it at the moment. So yes, for our future, we will build interest, raise funds, design and plan, hopefully prototype, maybe patent and distribute, so long as we are given the appropriate attention from A, the university, B, Tobii Technology, as well as the surrounding Lowell medical device developers. Thank you.